Hello everyone, and welcome back to MIS 5000 Special Topics in MIS, Python Programming. In this module, we're going to talk about loops and input validation in Python. We've already taken a look at the counter-controlled repetition and Sentinel-controlled repetition in flowchart form. We are now going to see how to turn those flowcharts into Python code. The learning objectives for this module are as follows. After this module, you should be able to describe and implement a counter-controlled while loop in Python, describe and implement a Sentinel-controlled while loop in Python, describe and implement a for loop in Python, define and use an index or counter variable in Python, identify the termination condition of a for and while loop in Python, use a random number generator in Python, and validate input using while loops in Python. We're now going to look at the third and fourth pieces of logic included in your textbook. So do this action that number of times, which will be our counter-controlled repetition, and keep doing that until this condition is true, which will be our Sentinel-controlled repetition. We are going to talk about both while loops and for loops in this module and demonstrate them in Python code. We'll start with the while loop. What I find is that when we start with the for loop, we have preconceived notions about how loops work. So I actually like to start with the while loop because it really makes you think about all the moving parts of the repetition, and then you can actually tease that out of a for loop when you need to. So here's an example of a simple while loop. First, we set our index variable or counter variable I to 0. We then start our while loop with the keyword while. We have parentheses here, which are not absolutely necessary, but I included them anyway. So while I is less than 5, we then have a colon. Notice we have the tab out, and what we're going to do while I is less than 5 is set I equal to I plus 1, and then print I. So if we think about what this loop is going to do, we have only one variable here. We set I to 0. We first check, okay, is 0 less than 5? That's true. So we then set I equal to 0 plus 1 or 1, and we end up printing 1. I is now 1. We check is 1 less than 5? It is. So we then set I equal to 1 plus 1 or 2, and we print 2. This process will continue until I is equal to 5, and will terminate after I is equal to 5. So when I is equal to 4, we have this evaluate to true because 4 is less than 5. We then set I equal to 4 plus 1, or 5. We print 5, and then when we test the loop again, 5 is not less than 5, so the loop will terminate. So this loop will print the numbers 1 through 5, and then it will terminate. It's important to be able to recognize the termination condition in every loop so that you make sure you do not end up with an infinite loop or a strange loop, in other words, a loop that will run forever without terminating. A while loop will execute a block of code over and over again as long as the while statement's condition is true. It consists of the following, as you saw in the previous example. First, the while keyword, a condition, so in the last case, while I is less than 5, it will be an expression that evaluates to true or false, and it will keep running while that condition evaluates to true. We then follow that with a colon, and on the next line, an indented block of code. This is called the while clause. We have already visited this in our own flowcharts. We check to see if spam is less than 5. We actually don't have any assignment for spam, so in this case it would actually be false and terminate. But if it were less than 5, we would then print hello world, add 1 to spam, until spam reached a value of 5 or greater. One of the most common applications of a while loop is that of computing a running total. So we're going to do the following example. Let's find the sum of all the integers from 0 to 10 inclusive. We will use the variable total to hold the total sum, and use the variable num to hold the current number in the sequence. So let's go ahead and take a look at this example in Visual Studio Code. I've commented the instructions at the top. We're going to take a running total of the integers from 0 to 10 inclusive. We're going to use the variable num to hold the current number in the sequence. So I'm going to start by setting num equal to 0. I'm then going to start the while loop. So I'm going to say while num is, in this case, less than or equal to 10. I could also say while num is less than 11. Add my colon, and then what we will do is calculate the sum. In order to do this, we will set our total variable equal to the current total plus the value of num. In order to check to see what's happening inside the loop, I'm going to print inside the loop the following. I'm going to print the value of num first, and then I'm going to also print the current total. Now I have to be a little bit careful here because I haven't initialized the variable total, so I need to actually do that as well before we start the while loop. I'm going to set total equal to 0. The last thing I'm going to do is finally print the final total outside of the logic of the while loop. So I'll simply say print final total and add the total. Let's go ahead and run this. Of course, I forgot to cast total and num as strings when they are being printed, so let's go ahead and do that as well. Now I wanted to show you this. You just saw that I actually never increased the value of num, and so it just kept running forever and ever. This is a very common mistake to make, and I wanted to show it to you for the first time in action here. What I did in order to make the program stop running was simply hold Control and press C. The last thing I'm going to do is increase the value of num by 1. So I'll do num equals num plus 1 inside of the loop, save and run again. And now you can see that the loop in fact does terminate, and you can see how the running total actually progresses as it runs. So num starts at 0 and moves from 1 all the way to 10. The final total is that of 55. I'm not sure if you've run into the creation of an infinite loop yet, but you likely will in your travels just from some silly mistake. Make sure that you increment your counter variable and make sure that you initialize both your running total variable as well as your counter variable when computing a running total. We're now going to revisit the bouncer and the indefinite loop bouncer example from the previous module. So recall this flowchart in which the application asks a user how old they are and tells them either to grow up or join the party if they are 21 or older. Now this flowchart here doesn't have any repetition. It simply checks to see if the user's age is 21 or greater and tells them either to join the party or grow up based on that input. We're going to start here and then move to giving the user a chance to increase their age. The first thing we need to do is prompt the user to enter their age. So I'm going to set the age equal to an input with the prompt how old are you. I'm also going to remember to cast that input as an integer. Let's ask how old are you. The next thing I'm going to do is check to see if the age is greater than or equal to 21 using an if statement. So if age is greater than or equal to 21, we will take the action on the true branch. So we'll print join the party. Otherwise, so I'll use my else statement, which applies to the false branch. I will print grow up. This is actually the conclusion of the code that matches the flowchart. Let's go ahead and save and run it. How old are you? I will say that I am 20 and it tells me to grow up. I'll run one more time and test the other case. I'll say I'm 21 and it tells me to join the party. Let's go ahead now and give the user an opportunity to change their age. So I'm simply going to comment this code out. I will post all of it on Blackboard for you to use. Okay, so again, we start by asking the user for their age with a prompt. We'll set the age equal to remember to cast using the int function. Int input, how old are you? I leave a space. Remember that this example is that of a Sentinel-controlled loop. So in other words, it will terminate when the age is finally greater than or equal to 21. So if the user happens to enter the age of 21 or greater, it will terminate after saying join the party. If the user inputs an age that is less than 21, it will tell them to grow up, and then it will prompt them again to give them an opportunity to change the value of the age variable. This process will repeat until age is actually 20 or less. To accomplish this, I'm going to use a while loop. Now this is a little tricky because the temptation is to say, well, while age is greater than or equal to 21, I want to do the repetition. In fact, it's the opposite. If the user puts in criteria that matches age greater than or equal to 21, we want the loop to terminate and allow them to join the party. Because of this, we want to set the while loop condition up so that it's actually the opposite of the condition in the decision. So in other words, we want to run the while loop so long as age is less than 21. We could set this up multiple ways. We could say while age is less than 21. We could say while not age is greater than or equal to 21. We could also say while age is less than or equal to 20. Either way, we just want to make sure that the loop runs until they enter an age that is 21 or greater. So just be aware of that while you are writing your while loops, that you are taking the condition inside the decision and making sure that it runs so long as that condition is not met. So let's continue. While age is less than 21, we're going to first print grow up, and then we're going to actually prompt them again to enter their age. To do this, I'm simply going to copy the line of code from line 1 and add it inside the while loop. At this point, the last thing we need to do is add what happens when the condition is finally satisfied. So I need to tab back out to the start of the indent of the while loop in order to do this, and then simply print join the party. I'm going to save this and now I'm going to test it. So what I want to test is I want to see if as long as age is less than 21 that the loop actually keeps running and that it keeps prompting me to re-enter my age. Let's go ahead and run it. How old are you? Let's say 19. It says grow up and it prompts me again. How old are you? Say 20. Grow up. How old are you? Let's say 21. Finally, it says join the party, and you can see that the entire program terminated. So again, the tricky part here is to make sure that you are including the condition in the while loop that is opposite that of the decision in the flowchart. We're going to take a look at several additional examples. Another common application of repetition is that of validating input. So we can use a while loop to get a user to enter valid input. We already saw this in the example of having the user guess a number until it matched the computer's number. We're also going to demonstrate the use of a random number generator in this module as well. Let's take a look at the following example and then test it in Visual Studio Code. So first we have this variable name, which we set to the empty string. We do this to initialize the variable so that the loop will actually run. We then start our while loop. So while name is not equal to the string your name, we then prompt the user for their name. So essentially we're looking for the user to enter your name, the text, and then the loop will terminate. Let's take a look at this example in Visual Studio Code. Here I have initialized the name variable as the empty string. We then set our while loop condition to while name is not equal to the string of your name, and we ask for input, enter your name. We could also add escape characters here to make it clear that we want them to enter that as text. And let's go ahead and run it and test it. So enter your name. I'm going to enter my name, and you see that that doesn't work. I'm going to finally enter the text your name, and you'll see that it does terminate. Let's also test the following. So I'm going to comment out the first line so that we don't initialize the name variable. I'm going to go ahead and run that. And what you'll notice is that we get this error. So name is not defined. That basically once we get into the while loop, we check, okay, is name equal or not equal to your name? And in fact, it doesn't have a value at all, so we can't test this. And so this is just to let you know that it is very important to initialize that loop control variable. Before we get into another example of input validation, we'd like to introduce the random number generator in Python. So we can generate pseudo-random numbers in Python in various ways. But what you have to keep in mind is that the random module is not preloaded in Python, so we have to import it. When we want to use a module that is not preloaded in Python, we have to import it. So for example, the random module. We're going to use the keyword import to import the module. If you would like, you can also use the keyword as to give the module a nickname. For example, import random as rand. This is because we're then going to call certain functions on the module random. In this case, we're going to use randint to generate a random or pseudo-random number between two integers, inclusive. Before we head over to Visual Studio Code, let's take a look at a couple of different ways we can use the random number generator. So we can generate different random numbers using the pseudo-random generator. The first function is that of simply random, which will generate a random float between 0 and 1. We're going to use randint in this course quite a bit to generate a random integer in the range 1 through 10, inclusive. We can also use the function uniform to generate a random float in that range. Let's go ahead and take a look at an example of how to use the random number generator in Python. So the first thing we need to do is import, using that keyword, random. You can also choose to call it something else by saying as, for example, r. In this case, I'm just going to simply use the name random. Let's go ahead and generate a random number. I'm just going to call it number and set it equal to, the way we're going to do this is first mention the random module, use a period, and then we're going to use the randint function to generate a number between 1 and 6. Let's go ahead and see the result. So we're going to print number, and we get the number 5. We could put this in a loop to generate several different pseudo-random numbers, or we could just keep testing to see what we get. We get 4, 4, 2, etc. You get the idea. And you see I did get a case of 1, so it is inclusive 1 through 6. Okay, we're now going to recall the example of playing the number guessing game with the computer. So we have this flowchart example where we first set the actual computer number equal to a random number. We will decide if it's a number between 1 and 10 or a number between 1 and 5. We're then going to prompt the user to take a guess, and then we're going to run this while loop that checks to see if the user's guess matches the computer's number until it actually does. And we're going to reprompt them to keep guessing until they meet the computer's number. In order to make this work, we do have to import that random module first. So I'm going to import random. Next, we're going to have the computer select its random number. Let's say between 1 and 10 to keep it simple. So we'll set actual equal to, again, remember to use random first, dot randint. I'm going to call numbers between 1 and 10. Then we're going to prompt the user to guess. So we will take in their guess and set it equal to, remember to cast as an integer, the input function. And just simply use the prompt of guess to get that done. Now we have our while loop. So we are going to run the while loop as long as, remember that it has to be the opposite condition. So we actually want to run the while loop so long as the guess is not equal to the actual number. So in this case, it will read while guess is not equal to actual. We are going to first print, sorry, incorrect. We are then going to reprompt them. So I can do this by just simply copying line 5 and adding it inside of the while loop. This will run until the user's guess matches the computer's number, after which the loop will terminate. We'll come back out to this logic here, and we will print congratulations, the number was, and we'll cast as a string the actual number, and add a period. Let's go ahead and test this. So let me take a guess. I'm going to just run through the numbers 1 through 10. 3. So the number was 3. So if I wanted to get more information while testing about what the number actually was, I could print it to start. So for example, print actual. Again, remembering to cast as a string. This will obviously ruin the game, but this is just for the sake of testing. So it prints the number 4. So let me test all the other numbers. So 1, 2, 3, 5, 6, 7, 8, 9. And if I do 4, I get congratulations, the number was 4. I will then remove that statement to make the game kosher once again. So again, remember to run the while loop as long as the condition that you're looking for to be satisfied is not met. So in this case, we want to run the loop as long as the person's guess is not equal to the computer's actual number. And we want to make sure in the Sentinel-controlled case that we are in fact giving the user an opportunity to update that guess so that it will eventually be able to be true. Let's take a look at one other example that we did that was a Sentinel-controlled loop. We're then going to move to the examples of counter-controlled loops, and we're going to look at them in the context of both while and for loops, because you can use both while and for counter-controlled loops. So remember this example, this was that of rolling a 6-sided die, displaying the number on the face of the die as output, and rolling until the number 3 is rolled 10 times, after which we get the number of times that each face was rolled as output. So I'm just going to simply start at the top of the flowchart. You'll see that we have a variable that holds the dice roll. which is going to be a random number between 1 and 6. With that in mind, I know that I need to import the random number generator again. We then have 6 additional variables, each one that keeps track of the number of times each face value was rolled. So the first thing I'm going to do is import that random module again. I'm then going to initialize all of our variables. So I'm going to set 1s equal to 0, 2s equal to 0, and so on. Finally, 6s equals 0. Now what we want is, we want the loop to run as long as 3s is less than 10. So as soon as 3s hits 10, we want the loop to terminate, and we want a printout of all of the number of times that every other face was rolled. So we're going to set this up in the following way. We're going to say while 3s is less than 10, again taking the opposite of the decision point. I'm going to then roll the dice. So roll will be equal to, I'm going to call that randint function on random. So random.randint 1 to 6. And then going to print the value of the roll, making sure again to cast it as a string. I'm then going to check to see if the roll was a 1, 2, 3, 4, 5, or 6. So this is going to be accomplished using an if-elif process within our while loop. So it's going to look like this. First, I'm going to check if roll is equal to 1. We are then going to increase, so say 1s equals 1s plus 1. Elif, roll is equal to 2. 2s equals 2s plus 1. You can see where this is heading. I'm going to finish the case statement with another elif. Roll is equal to 3. Then 3s equals 3s plus 1. Elif roll is equal to 4. 4s equals 4 plus 1. Elif roll is equal to 5. 5s equals 5s plus 1. And finally, elif roll is equal to 6. 6s equals 6s plus 1. Now this last condition I could set up as an else instead, because the nature of the randint function ensures that we're going to get a number 1 through 6. I could also leave it this way. This is the only bit of logic, even though it looks long, that's going to be included in the while loop. The while loop terminates when we have rolled the number 3 at least 10 times, after which we're going to exit the while loop, and we're going to give a printout of all of the number of times that we rolled each face. So in order to do this, I'm going to scroll down and exit the while loop by bringing my indentation back to where the while loop started. And then I'm going to print the following. So I'm going to print 1s, followed by casting the 1s variable. To make this a little bit faster, what I'm going to do is, since I know I have 6 of these, I'm going to copy paste and then modify them as I go. So the next one will be 2s. The next one will be 3s. 4s, and so on. First change the text and then update the variables here. So now we'll update the variables. We have 1s, 2s, 3s, 4s, 5s, and finally 6s. So up to this point, this is the longest program that we have written. You can see it's actually not terribly involved. We do have a while loop, and within that while loop we have case structure, so if and several elifs. The termination condition is that of when 3s is 10 or greater. Let's go ahead and run it. You'll notice in this one that there is no user input, so it's simply going to run and then hopefully terminate once we have 10 or more 3s. Go ahead and save and run it. You'll see I ran it. It printed out all of the different rolls. And then at the bottom, we see we rolled 1s 17 times. We rolled 12 2s. We rolled 10 3s, so that checks out. That's when our loop should have terminated. We rolled 11 4s, 2 5s, and 6 6s. If we wanted to, we could modify this to increase the termination condition so that we roll 3, maybe 50 times. We could change the number of faces on the die. This is kind of an interesting way to simulate different possibilities and then test the statistics and observe them when you are done. The only opportunity for having an infinite loop would either be if this randint function wasn't functioning properly, if we say omitted 3 from the random number generation, or if we again forgot to increase the value of the 3's variable once we actually rolled a 3. Now that we've explored the while loop and seen examples of using while for both counter-controlled and sentinel-controlled repetition, let's introduce the for loop. So what does a for loop look like? There are actually several different ways to compose a for loop. The simplest is that of saying for I in range, or for counter in range. That first variable can be anything you like. We then include the range that we want to see that variable run through in the parentheses, so in this case up to 5. We're going to print this is line plus the index variable, in this case I. Let's actually test this in Visual Studio Code so that you can see what it does. For I in range 5, we're going to print this is line plus cast as a string I and a period. So the question is, what does I start at when we call range 5? Does it start at 0 or does it start at 1? Let's run it and find out. So what you'll see is that in this case it actually starts at 0, although it does run 5 times. So I, when you call the for loop in this manner, will start at 0 and will terminate at the integer before the number of the range that you included. There are other ways to write for loops, and we're going to use a more common method shortly. To write a for loop, you're going to use the keyword for, followed by an index variable, the keyword in, and the range function with up to 3 integers as parameters. So in the first case, you saw just 1 integer as a parameter. We're going to most commonly use the function with 2 parameters, but you can also use 3. And of course, that for loop will be followed with a colon, and then the for clause. We have not yet looked at specifically the for loop in flowchart form. We've only looked at the while case. Here's an example of a for loop in flowchart form. We first print my name is, then we start our for loop. So for I in range 5, we print Jimmy 5 times plus the index. So in this case, it will print that statement 5 times, and I will run from 0 to 4 as we previously saw. The for loop can be used for that counter-controlled repetition, as we are initializing an index variable and then running the loop a set number of times. When you are writing a for loop, you want to ask yourself a couple of questions. So first of all, where does I start? And again, it doesn't have to be I. You could use the word counter. You could really use any word you like. Just understand that this is your index variable. Where does I start? Where does I end? What values is I going to take on while the loop runs? And then most importantly, what is the termination condition of the loop? Now, the reason I like to start with while loops is that in for loops, the termination condition is kind of set for you within that range. So in this case, what it's checking is, as I progresses from 0 to 4, it's going to progress to 5, but then the loop will actually terminate. So the termination condition in this case is, has I exceeded the range that was specified? So there's still a termination condition in a for loop. It is, has the index variable either exceeded or gone outside of the range. Let's take a look at a few more examples. This is going to be the format that I encourage you to use in this course. So here we have a for loop for I in range 2 to 5, print I. So I will start at 2 and then be automatically incremented until it reaches 5. Let's go ahead and just test this example. So here we have that example for I in range 2 to 5, print I, remembering to cast it as a string. Let's run it, and we see it actually runs 3 times. First I is set to 2, and it prints 2. Then its I is increased by 1, so I is now 3. It prints 3. We then increase I by 1 again to 4. It prints 4. Finally, it tests to see if I is still less than 5. Since I has become 5, this is no longer true, so it will stop running the loop and 5 will not be printed. I'm going to go ahead and comment this out so we can look at another example. We can also start our index at a negative number and run our for loop up that way. Here we have the example for I in range -5 to 0, print I. So this should print -5 all the way up to -1 and then terminate. Let's go ahead and test that. And you see, in fact, we get the numbers -5 through -1 printed to the console. The range function will increment the index in the for loop, and the range function can take 1, 2, or 3 arguments. So range 10 will start at 0 and increment up by 1, up to but not including 10. Range 5 through 8 will start at 5 and increment by 1 up to but not including 8. And finally, if we add that third argument, we have range 10, 23. This will start at 10 and go up by 3, up to but not including 20. So you can feel free to test those out on your own. Let's take a look at 2 more examples. Here we have for I in range -5 to -10, print I. Take a guess as to what will happen here. Let's go ahead and test this. So interesting, I didn't get any output at all. This is because the way this for loop is set up, you have to go from lower numbers to larger numbers. So in this case, this loop actually will never run. So because it starts at -5 and attempts to go to -10, we are checking to see if we are greater than -10. And since I already starts greater than -10, the loop will never actually run and we do not get any output. In order to make this loop run, we need to add 1 more argument to our range function. So here we have the following. For I in range -5, -10, -1, we're going to print I. In this case, what we're telling it is instead of increasing I by 1 each time, we're going to decrease it by 1 each time. Let's take a look at what happens when we add this additional argument. So I have now for I in range -5, -10, -1. I run it and you see that now we actually have a loop that does run. So I starts at -5. It is then decreased by 1 or increased by -1, however you want to look at it, to -6, -7, -8, and stops at -9 because it tests to see if I is less than -10 and then terminates. We're now going to revisit several other flowchart examples, starting with the example in which we simply set a counter to 1 and count the numbers 1 through 10 by printing them to the console. In this example, you can see that it is set up as a while loop. So we first set the counter to 1, we set our max to 10, we run the loop while the counter is less than or equal to max, we output the counter and then increment the counter by 1. This will look something like this. So first we set our counter equal to 1, we set our max to 10. Now I need to use capital letters here because max is actually a keyword in Python. You'll see that if I use lowercase max, it changes color. I'm going to use uppercase max, set it to 10. We'll then start our while loop. So while counter is less than or equal to max. What you'll notice here is that because this is a counter-controlled loop, we're actually matching the condition that is in the decision. So we're going to run this until counter is greater than max. So we're just going to check to see is counter still less than or equal to max. If it is, we'll output the counter and then increase it by 1. Let's do that inside the loop. First we'll print, remember to cast as a string, the counter. We could also use I. And then we will increase the counter by 1. Go ahead, save and test this, and you'll see we get the numbers 1 through 10 printed to the console. The loop control variable is the counter, and the termination condition is that when counter has a value that is greater than max. Let's take a look at what this would look like in a for loop. I'm going to go ahead and comment this out. Again, I will share all these on Blackboard. This looks slightly different. What you'll notice is that we have the for language inside the decision. So for I in range 1, in this case to 11. The reason behind this is that it will only print 10 if we set that maximum value equal to 11. And we only have the output of I in the loop. So the incrementing of I takes place automatically, but just understand that that is taking place. We do not have to include it manually in the flowchart. So this will look something like this for I in range 1 to 11, colon, print, cast as a string, I. You'll see that this is a little bit shorter. Again, because this is a counter-controlled loop, we can use a for loop for this. If I run this, you'll see that I do get the numbers 1 through 10. Again, making sure that we do use 11 as the second value in our range. You'll see that if I use 10 as the value, that it will only print the numbers 1 through 9. So just be mindful of that. It is not inclusive in the range. Let's now take a look at that counter-controlled example we had of rolling the dice. So this application asks the user how many times they want to roll a 6-sided die, and then rolls the dice that many times. Each time it's rolled, the number on the face of the die is returned as output. After the die is rolled that maximum number of times, then the number of times the number 4 was rolled is reported. So we have 4 different variables here. We have the number of rolls. We have a counter, which serves as the index variable for our rolls loop. We have our face value that holds the value of the dice roll, and then 4s, which keeps track of the number of 4s that was rolled. So because we are rolling dice, we're going to want to import that random module again. So we'll start with that at the top, import random. The next thing we will do is ask the user how many times they want to roll the dice. So rolls will be set equal to, remember to cast as an integer, the input of how many rolls. We'll then do some initialization. So set our counter equal to 1, initialize the face to 0, and set the current number of 4s also equal to 0. We're going to use a while loop for this, and then we'll also see how to do this with a for loop. So we're going to run this loop as long as the counter is less than or equal to the number of rolls that the user requested. So it'll look like this. So while counter is less than or equal to rolls, again in the counter-controlled case, we're going to match the condition in the decision. We will first increase the counter by 1, so counter equals counter plus 1. Be careful with this. In this case, this works out fine because we're not actually using the counter in any other way other than to determine if we are done with the loop or not. In some cases, you may want to increment the counter last, but here we can do it first without any negative consequences. We will then print the value of the roll. So roll plus, remember to cast a string, the face. The next thing we're going to do is actually roll the dice. So we will set face equal to random.randint 1 to 6. We will then print the value of the die. So roll plus, remember to cast as a string, face. Next, we're going to check to see if we rolled a 4 and increase the value of the 4's variable if needed. So if face is equal to 4, then we will set 4's equal to 4's plus 1. And that is everything that needs to take place in this loop. So we've made sure we don't have an infinite loop by increasing our counter by 1. We've increased the number of 4s if we rolled a 4. We rolled the dice and printed the roll to the console. Once this loop terminates, so we're going to back the logic up to where that while loop started, we're going to simply output the number of times that 4 was rolled. So we'll print 4 was rolled. Remember to cast as a string, 4's times. Let's go ahead and save and test this. So how many rolls? Let's just roll it 1 time. So we rolled a 3, so yes, 4 was rolled in fact 0 times. Let's test it again. Let's roll 10 times. And you can see all the rolls we rolled a 4 1 time. Just add a space here for my own edification. Just for fun, let's roll 100 times. We rolled a 4 24 times. So this is what this looks like in while loop form. We have a counter that we keep increasing until we reach the maximum number of rolls that we want. Let's go ahead and take a look at this in for loop form. So here you see we actually have the same number of variables. We have the number of rolls. We're using I instead of counter for our index variable. We of course have the face of the dice roll and the number of 4s. The difference here is that we don't initialize our counter before the loop starts. So we have this for loop here for I in range 1 rolls plus 1, because remember we need to set that termination condition correctly. If we only say rolls, it will stop short of one of the rolls. And the rest of the logic is the same, other than we do not increase the counter. Here in this process, it is taken care of automatically by the for loop. So first let's import the random module. Next, we will again ask the user how many times they want to roll the dice. So cast as int input, how many rolls. We will set our face to 0 and the number of 4s equal to 0. And now we'll start our for loop. So for I in range, 1 comma rolls plus 1. Remember, because if we don't add 1, it will stop 1 short. Then we continue. So inside the loop, we're going to set the face equal to random.randint 1 through 6. We will print what we rolled first, remembering to cast as a string. We will then add our if statement. So if face is equal to 4, increase 4s by 1. And finally, once the loop terminates, we will simply print 4 was rolled, and then the number of times it was rolled, remembering to cast as a string, and times. Let's go ahead and test this. So save and run. Let's roll 1 time, and you see we rolled a 3. 4 was rolled 0 times. Let's roll again and roll 20 times. We rolled a 4 twice. So you can see this accomplishes the same task. Because it is counter-controlled, we can use while or for in this case. We just have to be careful when we're using for to make sure that we run it all the times that we want to. In this case, we had to increase the number of rolls by 1 in our for loop. In the next example, we asked the user for their name and then spelled the name out letter by letter. So we first ask the user for their name. We then set a counter equal to 1. We're going to use this special syntax to get the length of the name and run the loop until the counter reaches the length of the name. So for example, if the name is Bob, this will be set to 3. We will then use this syntax to print out the letter at the current spot in the name that we're at based on our index. We'll increase our index by 1 and repeat this process until we are out of letters. Let's take a look at how this works. So the first thing we're going to do is set the name equal to what the user tells us. So we'll prompt them for their name. We will then set our counter equal to 1. We're then going to start our while loop. So we're going to say while counter is less than or equal to the length of the name. And again, because it is the length of the name, we're going to use less than or equal to. We're going to do the following. So we're going to print the name at counter minus 1. I'm going to explain why in just a second. First, notice that again, this is a counter-controlled loop because we're only running it as many times as there are letters in the name. Thus, we are actually matching the decision as it is written in our while loop. Now, if we take a look at how this works, so counter set to 1, let's assume that the name is Bob. So we first check, okay, is 1 less than or equal to length of name evaluates to 3? That's true. So we're going to print name at 1 minus 1, which is name at 0. The reason for this is that the way this syntax works is that name at 0, if the name is Bob, will give us the letter B. Name at 1 will give us the letter O, and name at 2 will give us the letter B. So the index within that syntax actually starts at 0. Because of this, we have to either start our counter at 0 or simply subtract 1 from the counter within that syntax. Either way, you just need to be careful that you are in fact printing what you want to print. Next, we're going to increase our counter by 1. That will conclude our while loop. We'll exit the while loop once we're out of letters and simply print goodbye plus the person's name. Let's go ahead and test this out with a couple of examples. So let's say that name is Bob. You can see we get the name Bob. We get every letter and goodbye Bob. Let's see what happens if I do omit the minus 1. It's going to ask me for the name. Let's put in Bob. And you'll see I actually get this interesting error. So string index out of range. Basically what it's doing is counter is 1. So it's cycling through in the following way. The first time it will be name at 1. The second time it will be name at 2. And the third time it will be name at 3. Now name it 3 in this case, if it's Bob, doesn't actually evaluate to anything because the BOB corresponds to name at 0, 1, and 2 respectively. If it tries to do name at 3, it's going to hit this index out of range error. So we need to make sure that either we use this and we change the counter to be 0 to start. We would also then have to change this, or we just subtract 1 in here. You just need to make sure you understand what is going on in each piece of this code. Let's go ahead and run it again with a longer example. And you see that it prints all the letters in the name and then says goodbye. Let's now take a look at this using for. So it is a counter-controlled loop, so we can use for. Let's take a look at the flowchart first. You see we prompt them for the name first. We then set up our for loop. For I in range, we run from 1 to the length of the name plus 1. In this case, it might actually be simpler to just run from range 0 to length of name and run the output as name at I. Either way will work. Just again, be mindful of what you are looking at. The counter, or the I in this case, the index is taken care of automatically by the for loop. So here's what this will look like. The first part is the same. We prompt them to enter their name. We then start our for loop. So for I in range 1 to the length of the name plus 1. Again, you could change this around. I will do that as an example. We will print the name at I minus 1, again, because we're starting at 1. Once the loop terminates, we will print goodbye plus the name and a period. Go ahead and run this. Asks for the name, let's say Bob, and you'll see that it prints all the letters and then terminates. The other option here is if we start our for loop at 0, we can get rid of this plus 1 and get rid of this minus 1. So the reason behind this is this will run through name where I is 0, 1, and 2. It will stop before 3, again, if we're considering the case of Bob, but this will function the exact same way. Let's go ahead and test it. You'll see name is Bob, we get all 3 letters, and then goodbye Bob. So again, just use your judgment to determine what each piece of code should look like based on your understanding of the length function, of how this operator works, and how the for loop actually works. The last concept I want to show you is that of nested for loops. So we can nest loops inside of other loops. In fact, you've already had an example of this in the cheerleader problem. In that case, you are nesting a while loop that checks to see if each letter is correct within a counter-controlled loop. So that could be for or while that runs through the letters in the name. A nested for loop is a for loop inside of another for loop. The way this works is that the inner loop, so in other words, the second loop, will finish running, and then once it terminates, it will return to the execution of the outer loop. So the way this will work in this example, for I in range 0 to 3, so for I in range 0 to 3, I will start at 0. We then enter this loop for j in range 0 to 3, so now j is also 0. You can see this on the side. I'm keeping track of the values of I and j. This inner loop will then run from j is 0 to j is 2. We will print the text that you see on the side. So this will run and print 0, 0, 0, 1, and 0, 2. So notice that that first number, because it is I, stays the same each time. Once the inner loop has terminated, we return to the outer loop. We increase I by 1. So now I is equal to 1. We enter the inner loop and then see that j runs from 0 to 2. So we get the following output of 1, 0, 1, 1, and 1, 2. Finally, we exit this inner loop again. I increases to 2, and then we run j from 0 to 2 again, so we get 2, 0, 2, 1, and 2, 2. You can test this on your own in Python. Eventually, we may use this concept of nested for loops once we introduce some additional data structures. If you have any questions about the for or the while loop or any of the examples that I ran through in this module, please let me know.